You want us to write that table?
It would not be a bad idea.
Get no money, tell them quit that cap.
Write it for number 3, right?
4. This is not really the table I originally designed or thought about, but this is what we worked on in group 1. What do you think? So notice we have our sizes here. Notice how I also labeled the sizes at the top. So what are the 1, 4, 9, 16, 25?
Where are those coming from?
The number of blocks of squares.
Yeah.
The blocks where?
Of the size.
Like each block.
So let's say this. Let's say that the big part is a square and that we have blocks on the inside of the square. Does that sound, can we use that language altogether? Does that help, Brooklyn, in you describing what you're trying to say? So where is that 4 coming from? With 2 and then 4, where's that 4 coming from?
Size 2
Remember, we're calling the big thing the square, and then there's the blocks on the inside.
is the square with the box.
Okay, so that's the square, and the 4 is how many blocks are inside of that square, right? So how are we getting this 28 over here? This is something I think, Tony, you did really well early on, and you realized, what are we doing to that 4?
We're multiplying by 7.
Okay, why are we multiplying it by 7?
Because there's 7 blocks.
There's 7, let's work on that language. We didn't say it was 7, remember, each little piece is a block. There's 7 what? Squares, right? Well, we got 5 minutes for you to learn as much as possible, so how about you focus on that?
I can't focus in cold.
You can. Step up.
That wasn't good.
Alright, so when I look at this 28 right here, it's coming from that 7 times 4, right? This 9, again, it's a size 3, so it's a 3 by 3, which I'm getting 9 there. And so how am I getting 63 total?
9 times 7.
9 times 7.
Good job, man.
And then this 16 is coming from the fact that each square is a 4 by 4.
16 times.
So 16 times 7.
Yes, sir.
And then it's a 5 by 5. So to get to 175, we're getting
25 times 7.
25 times 7.
Yes, sir.
You know we can create a graph on here?
Yes. So, from this point, Tony, we broke this down a little bit more in your group. What did y'all start to notice about how we could make an equation out of this?
By writing down 7 times n.
Well, but how did we get to the n times n idea?
Oh, because we noticed 7 times 5 times 5.
So notice this could be 5 times 5 times 7,
Yeah.
right? This 16 could be,
4 times 4
4
times
times
7.
notice how that's based on the size here?
Yeah.
So just making a prediction, if it was size 7,
7 times 7 times 7.
because there'd be 7 of those. And then if it was 8, it would be,
8 times 8 times 7.
so if we get all the way down to an input of n,
It would be n times n times 7.
so the total number of blocks would equal what? How would I write that expression?
7n squared.
7n squared.
Mm-hmm.
What type of equation is this that we just wrote?
X. O. H.
You think that's exponential? Is it an exponential function?
No.
No?
Explicit.
It's an explicit. Is this an exponential function?
Yes.
Yeah.
Why?
Multiplicative rate, constant but is it?
Is it constant multiplicative rate of change? To go from 7 to 28, what would I multiply by?
It's quad. Is it quadratic?
28 times 4 would be what? 112? Is that 63?
No.
So are we constantly multiplying?
No.
Okay, so maybe quadratic. To go from 7 to 28, we are
Hey, Pax.
adding how much?
Did you check your email and find out
21?
for the latest Pax
28 to
episode and
63
share with
is
the students?
35.
This year was
63 to
17 transfer
112 is
to
49.
14. Pick up an order
112
form from the office
175
for your
is
original
63.
teacher. Size is small, big extra large, by
Is it
15.
quadratic? Have we
So
proven
these
it yet?
periods are 18.
What do I
Send
still
them
need to
in no
see?
later than April
The
6th.
second
The
difference.
second set of differences.
Yes, sir.
All prom tickets must be picked up by Wednesday, April 7th. Tomorrow, Miss Pratt will be selling them in room 113.
If that is constant
And
additive,
Monday, Mr.
what type of function has a
Most
constant
learners
additive rate of
pick up
change?
Today at 3:30. The
Linear, right?
front.
So then this first set of differences, the rate of change
Every Friday
is,
between classes,
Linear.
especially
Linear.
the classroom will be holding paper snatch day. With lots of
and
trips
so
from
what type
around
of
the week.
function is the total
I'll
blocks?
to go to the classroom for room
Quadratic.
150 or 200. Thank you and have a great day.
So it's a quadratic function. Please note, what is the highest power? 2.
It's quadratic.
Because it's quadratic, because every quadratic function has what as its highest power? Second power, right? Remember, exponential has the variable as the exponent. Tomorrow, we're going to pick up with the recursive and do some comparison, but here's your homework. 6.2, ready, numbers 5 through 6.
Ain't no April Fool's.
Set number 11, go numbers 18 and 21. The April Fools would be me not giving you homework.
I was about to say.
Like,
Yeah,
so there's
yeah,
your
yeah,
homework.
Yeah, that's what I was waiting on. You say April Fool's. But you didn't say it.
Yeah, like, no, he's saying like nicknaming of like,
I'm saying-
today we're not gonna have homework.
That would be the April Fools. You having homework all day, every day.
Go section? Oh, them go section for these. I'm not worried about them go sections.
It's just 5.
Yeah, them go section for these.
Last night was 5. I never give y'all more than 5.
No, I'm talking about like the go section.
Oh.
Oh, the